we start creating a code for this simple exercise, and we will experiment like getting these LEDs blinking with different kind of timing sequences. So practicing with the treats. So you will need this kind of connection. So a microcontroller, the wires to the LEDs, and from the LEDs to the resistors, and from the resistors back to the microcontroller ground. So with the on or true on the output, you will get the LED on. And with the false in the output, the LED will be off. This time we don't use this potentiometer in here. So it's for the next exercises then. So I will leave the image of the real one in here, or I can probably also leave the image of the connection in here. So I'll explain how to create the code for us. So I will start by defining variables, the global variables. So those are not only for the main program, but these are really global. And then it's the digital. You see, this is how do you say it? Syntax sensitive or what? So it knows that from the operating system that when I have something digital, I have either digital inputs or outputs or in-outs. So I'm using digital out class, and then defining there just like my own name for the LEDs or something. So I'll create from the yellow, and this one I'll connect into TE. Let me see, I'm using this first one in here. So it is on my, it's from here. So that one goes into D2 in here. So in here we go into the D2. So I'll start from the D2. And then a similar one, digital out, and it is an LED, and then the next one is an amper, and it is connected into the tree. And then another digital out, oops, out, and it is an, again, the LED. And this one is a red one. And D4. So of course I can use the copy paste as well. So I have 4 LEDs in there. And I have even a white one. So you can either use exactly the same names as I have, or you can name those, right? You have the colors in yours. So I'm using these as an global variables because actually whichever of my treats or subroutines or whatever is trying to control the something which is connected into the D2. I mean, it's the same. It should be the same variable. It's better not to define inside another subroutine or inside the main program or inside some treat, and there inside the program another like a variable which is referring to the same hardware thing. So that's why I use these hardware, let's say, connections as a global variables. So then, yes, I promised that we exercise with the treats. So this is a treat. And so this is the treat class. And then I name it as a treat 2. because I think my main program is the treat one. So another treat, which I named the treat tree. So I have there now the main program, which is in the main treat. And then I have the treat 2 and the treat 3. And I can run now several programs, like I'm like running those completely parallel. So they are like independent of each other while I'm running the other program in another treat. And then what else? I'll go into the main and I will define there that I will start a treat. So when I go into the code, I have defined these like classes and objects and these treats, and then I go into the main, and in the main now I'm starting the other treats as well. So treat, so it knows that I have the treat 2 and treat 3, so my treat 2, and I will say for that one that, so this is the like an object. So the object is defined in this treat class definition, and then I have different methods in there, and I have the, wait a second, I have more than these. So for just a moment, I should have there like treat start. I'm using this kind of callback, and then I start a program which I will then create as like a program in here, and then I will call this one like this is the program let yellow. So this is my starting for the treat 2. And then I'll go into treat 3. And in that one, I will also start the program. I also set it in a callback function. And then I'll call that one let A. That's my amber. Amber is like an orange. And now I need to go and define these functions or the subroutines. So before getting into here, I need to go and then define a routine there. So I need to go and define a void. Void is like a variable type which is not returning anything out of the function. So I run a function let y, or function subroutine, and then in starting I'm not giving it any parameters, so that's empty. And then I start my function from there, and then write the definition inside in here. So And then I'm making there a simple while loop, while it's true. So while true, and start the loop in there and define what is happening there inside that one. So I'm using my LEDs in there. So I take my LED yellow. So LED yellow. And for that one, for the LED yellow, I'll use a method write. So I can read the value from the LED, what is there in the output. But I'm now writing there in the output. So I'm taking this one, and then I'm writing there a true value. So I'm writing there true. And then inside this thread, I'll put there a timer, timing event. So I say this, notice that I'm writing this thread. And in this thread, I'm using the sleep 4. So it's the last one in here, sleep 4. And I can write here how many milliseconds. I'm writing here 200 milliseconds. Now it depends on the version of the operating system if it needs the milliseconds here or if it doesn't need the millisecond in here. So it might work like this, I think not, because now it's with the MS. I think it works only with the 200 ms in there, in this version of the operating system. And then after 200 milliseconds, I'll just go there and write to the same LED again. So LED, my LED yellow, and using that method write. And this time I'm writing there the false. Like this. And putting this one again. This thread. And for that one, the sleep 4. There are sleep 4, sleep until, and so on. But the sleep 4. And then 200 milliseconds gain. So that's my first thread in here. And in the similar manner, I should define the next, or this is my subroutine let y, which I'm calling here to be run inside the thread 2. And in the same way, I'm writing here the other. I'm not repeating myself that much, so I'm copying this one and defining there another thread. So, or another subroutine, which I will call then from another thread. So I call this let A. So this is the let A. And then it's my let amber, of course. Let amber in here. Yes. And then I will put it to run so that it runs definitely a longer period. So I think I'll do it like this. Wait a second. Yes, I know. So it blinks for 200 milliseconds, and then it goes I mean, it's true, and it is waiting for 200 milliseconds. Then it's writing there false, and it will be waiting for 2,800 milliseconds. And then this thread sleep for is exactly what it is saying there, that on the processor, central processing point of view, it is putting the processor in the sleep mode. So if no other thread is calling the processor is in the sleep mode. Then I still need to go and complete my while loop in here. And I think that I'm just making here a simple statement in my while loop. So I'll print on the monitor in here. So hello from the main loop. And then what?
Ne on ne threadit siinä kaarisulkujen väärällä puolella.
So yes, I had these. There is the warning, the red color in here. So these are actually, I wrote those accidentally on the wrong side of this. So. What? Now I have cleaned my code, so I needed to have, of course, these thread definitions in my main program, so it's inside the in here. So, and then I'm printing there just a hello from the main loop, and if I'm not putting there anything like this thread sleep for, it will print this like a mad. I mean, as in a loop, so that it will be all the time printing. So of course I'm putting also in here that this thread sleep for. So this thread sleep for, and then like 2000 milliseconds. Like this. And still my clean coding, so there is the semicolon missing. Now it's correct. Looks like correct. And then I can compile the code. So everything should be all right. It's for this target hardware, and I'm in the debug mode, and then I can build the program. And now in the background, it is building my program. It takes a while because it's compiling the whole operating system. So I couldn't see what's happening there while it's compiling the operating system. So I selected from the view and then output, and then on there, now I can see that what it is doing. I'm also opening the problems view, so that if there are any problems, so back to the output. And then I'm also opening this serial monitor in here. So if I connect the hardware, I will get the USB serial working, and then it's monitoring what's happening in there. And while it is doing that on the background, I can try to connect my hardware and have a look at if things. So I have the hardware in there. And that's the monitor from that hardware. It's working with the speed and so on. But in the output window, I'll still monitor what's happening in there. So the build is finally done. So I got the, so that it's built, and then there is an image, this build Nucleo, and so on, treats, and the bin file. If you are in the online compiler, this bin file will be on your download folder, and then you just take that bin file from the download folder and drag it to the folder which is for this Nucleo board. But then in this locally installed Embed Studio, I go into the debug. And I have the output window in here. So not in the debug, but simply in the run program. And then it is, I have this board connected, and there is the live video on the right. And then it's writing here on the Nucleo window on the serial monitor in here, because I opened from the view serial monitor, and it was opening this page in here. And on that page, I'm writing there, hello from the main. And I'm writing this hello from the main once in 2 seconds. And then I have 2 independent blinkings going on. So the other one is blinking like 200 milliseconds on, 200 milliseconds off. And the other one is blinking that it's on for 200 milliseconds and off for 2,800 milliseconds. So it's running, and we have the timing of the events done. And then if you think about it just a moment, how to get the real clock in here, so real-time clock signal, how to get it showing that, or for example, that it's blinking once in an hour exactly on an exact hour. That's not possible right this way, because this processor type hasn't got a real-time clock. So it's not you can't set there a time, your time zone, and then let it run. So it's not a precise lock. So this is quite exact milliseconds, but it will lose the accuracy anyway. It's just an oscillator inside the microcontroller. So the better accuracy on the clock you typically get with a crystal oscillator. And then in this one, there is, I'm not sure if they're on the board, there is an external crystal or not. We can have, if you're interested, you can have a look on the circuit diagram of this board, if it is using an external crystal oscillator or if it is just using the internal oscillator from the microcontroller.